Well, if you're here, you probably already know about Three.js. Three.js, that's a JavaScript library that makes building 3D experiences for web much easier. Actually, Three.js sits on the top of WebGL and takes care about heavy lifting. So instead of struggling with low-level code using pure WebGL, you can focus on creating interactive 3D scenes. So here we have some examples, but before we check them, let's check what is WebGL. So WebGL, that's a browser API that uses GPU to render graphics on high speed. We can draw different shapes like triangles, squares, boxes using this native browser API. So here you can check how it works, guides, tutorials. For instance, you can simply play around with it. And here we have a simple example how we can create rotating square using WebGL. So here we have a pure vanilla JavaScript and we use WebGL to create this great square and this animation. Well, as I said before, Three.js uses WebGL, simplifies it by providing an easy interface for scenes, cameras, lights, animations, shapes, and so on. So with just a few lines of code, you can have a working 3D scene without writing your own shaders or creating it from scratch. Well, here we have some great examples where people used Three.js. Let's check some of them. This is the first example that Three.js website provides. Okay, as you can see, we have some 3D animation, and once I scrolling, it rotates this 3D object. So I can scroll down and see how it works. It works great. We have a great, beautiful animation with our cursor. So that's one of examples how beautiful Three.js can be. So let's check, I don't know, this example. So we have 3D model that rotates once I scroll down, customize it. So we can check, rotate it, and so on. Car visualizer. One more Three.js example. So here we can rotate, check this 3D model, and if I don't do nothing, so it rotates automatically. One more, Earth 2050. So here we also have Three.js implementation, map, feed. Okay, one more beautiful example. Once I click on examples here, I also have 3D models in Three.js and we can simply rotate them. Animations, so I can also pause, continue walking. We can adjust some parameters. For example, modify run to wait. For example, modify run wait. Okay, it works perfectly. And a lot of another examples how it works. Animations, scenes. All these stuff you can implement using Three.js. So here we have some cube, interactive cubes, and so on. Before we will move on, I'd like to remind you that you always can check the Three.js documentation. Three.js has pretty straightforward description how everything works, so I leave the link in the description. Alright, let's move on and create our first Three.js application. But before that, I would like to remind you that I have my own Telegram channel, and sometimes we are looking for developers, especially with Three.js knowledge, because a lot of clients want this 3D animation, so that's why we use Three.js WebGL in such projects. Of course, React, not just knowledge and so on. So some of projects that's 6 months duration, some of them shorter or longer, but primarily we focus on long-term projects. So I'm gonna work with wheat. Well, I'm not sure how to say it correctly, but anyway, usually I say wheat. So let's name Three.js project and create. Yes. We're gonna use vanilla JavaScript, at least for start, then we will move to React.js. Right, here it is. I'll just drag and drop the Visual Studio Code. Here what we have initially in Vite project. We have main.js, JavaScript SVG, counter. Let's clean everything up, remove it. I don't actually need two JavaScript files, so remove also this. We don't need SVG. Let's create script.js. That's gonna be fair enough. Here we will change the path to script.js. And let's check does everything works. Hello. npm run dev to start up a server. Okay, we've got an error because we forgot to npm install. Now we can run npm run dev and it works. So I'm getting hello alert. It means that we added our script correctly. So here on the right side we will have browser, on left our Visual Studio Code, and also I have a small block of presentations that will help me and help you as well to understand what is going on. So I guess we can hide our terminal, and first of all let's simply import everything as free from Three.js. Of course, it won't work because we forgot to add Three.js to the project. Let's add Three.js as dev dependency. npm install -- save free and run again our project. Now we don't get any errors anymore, and let's console log and check what we're getting. So here we're getting the whole big, really massive object of all properties and methods inside Three.js. Well, in future, if we will need something, we will say like free dot let's get any random method, for example, normal blending. So that's how we're gonna work with it. And the first thing that we need in every single project with Three.js, that's the scene. The scene, that's, let's say, a container for all our 3D world. So we will put there inside all our objects, lights, helpers, 3D models, and so on. So I will say const scene free.scene. The next what we need is canvas. So inside HTML, our index.html file will create new canvas with class scene. All what we are doing now, that's like initial setup for every Three.js project, especially when we're working with vanilla JavaScript. In React.js, this process a little bit simplified, but anyway, you need to understand this process of setup. So here we add scene. Now we create canvas, document, query selector, canvas. So here, as you can see, it says that we pass this canvas to WebGL renderer. So Three.js knows where to draw. Let's save also index.html and let's check did we really get that canvas. Well, now I can hover over and see where it's located in our body. Well, as the next step, let's define our sizes. We don't need actually yet. In the future, we will need to define our sizes of scene, canvas. We also will need it for some parameters in camera. Let's create a separate object const sizes. Widths. Usually people say like window inner widths and height window dot height. So which means that width is gonna be window width So the entire width of our window viewport, like from here to here, and height the same, the entire height in our browser. But let's put here 800 and 600 as well, just to let you play around in future and let you see that how it works. Now let's create camera. Camera, actually that's very important one. There's a few different camera variants, but we will go with perspective camera. That's the most common one, and probably you will use this in your future projects as well. So free perspective camera. All these objects and things you can check in Three.js documentation. So here we have perspective camera. You can check and read about all its own methods, properties, how it works, what these parameters about, and so on. Perspective camera gets few more parameters inside. I'm not gonna talk a lot about all these parameters right now, but I will explain it. But I will properly explain how all of them works in future. Ideally would be if you could Google now and check how everything works, or just simply play around changing all these parameters here when you create camera. So here let's put 75 as field of view, then as an aspect let's put sizes, width and sizes 8. The nearest objects that camera can see, that will be 0.1, and the most far, that's gonna be 100. So let's save the file and move on. The next is renderer. Okay, let's close up our terminal, and I would like to remind you one more time that we set up, let's say, the environment now. We need to do it once, and if you struggle to remember or can't understand something right now, that's completely fine. So you need to set up it once, and that's it. So now const renderer, that's gonna be new free WebGL renderer, and this method takes object, and here we need to pass canvas. So canvas is our canvas that we created above here, but since the name of variable is the same as our property, we can simply say here canvas and do not duplicate that name. Let's save it. Then let's say render. We provide our scene, and also we provide camera. Now we save, and here instead of transparent block, we have a black canvas. So that's our canvas with class scene, but it's still too small. So to change the sizes, we need to say render set size and provide the width of our renderer sizes dot width and the height. Once I save, we have the canvas with width 800 and height 600. That's exactly what we have inside our sizes. If I will change width, for example, to 950 and save, as you can see, now our canvas is wider. Okay, great. Now we're ready to create some objects and render inside our scene. Well, Three.js has some special methods that allows to create some objects. For example, box geometry. Let's save that. Let's create that geometry. And it takes three parameters. That's width, height, and depth. Let's put 1, 1, and 1. It's not pixels, rams, ems, meters, kilometers, or so on. That's like a number that doesn't relate to any of them. That's, let's say, like a default measures inside Three.js. So I put 1, 1, 1, and which means width 1, height 1, and depth also 1. The next, we need to create material. So we can't actually in Three.js create a geometry and put it in our scene. We need geometry and material, and then we need to combine them. To combine them, we need to use mesh. Material in Three.js, that's something, let's say, that can determine its color. So I will create new free mesh basic material color, let's say blue. So now we have geometry, that's our box. Now we have material, and we said that's gonna be blue. So material doesn't know about box yet. Box exists, but it wasn't added to our scene. Before we will add our box to the scene, we need to combine these two together. And to do it, we need to use mesh. So we'd say const mesh, new free.mesh. And here, the first we need to pass geometry, and then we pass material. After this, we say scene, let's add our box. Oops, sorry, let's say our mesh. So remember, mesh, that's geometry plus material. I saved, and we don't actually see anything. That's because actually our box, it's not really box, it's a cube, because we in 3D world inside our scene. So our box, cube, that's the name, is located in follow coordinates. That's x0, y is 0, and z is 0. Our camera, our scene is on the same coordinates. To fix that, we need to change position of cube to make it visible. For example, we can say cube.position dot that -3. Now we can see our cube. Obviously, we can change the cube position dot x, y. Let's say position x is 1. And here now we can see the depth of cube. And now we can observe that this is actually the 3D world. Let's play around with depths. Let's say 3. The depth was increased. Let's say 5. It's much bigger now. Let's get back to 1. Also here the width, we can say, or it's not the width, it's that's the height. 3. If you will put 3, 3, and 3, it's gonna be still cube, but now we don't see the depth. Let's put 3 here as well, and that's the depth of cube. That's how it works in Three.js. Again, these numbers here, here, and here, that's not matters, centimeters, pixels, rams, viewports, or something. That's just simply numbers. So you can play around with that. You can change the color. For example, let's say yellow. We can also provide here in another format. Oops. So at least, well, finally, at least we added 3D geometry in our scene. We can observe it, change position, and well, everything works. And let's save our progress. Well, you actually can download this project from my Telegram channel. And if you struggle somewhere or get some errors, simply want to copy some part of code or play around with my cube, you can download this project. You can download this project in my Telegram channel. That's completely free. Just need to... Блять. You can download this project in my Telegram channel. That's actually completely free. Just needed to mention that. Alright, so we can change cube position in Z axis, X and Y. Y we can set, for example, -1. It will move down. If just simply 1, it will move a bit to the top. Also, we can change the scale of object. Initially, by default, it all set to 1. Let's make a bit bigger font size. I guess it will be more readable for you. So we can change the scale, and let's try to play with that as well. Object scale X if I will put 1, nothing will be changed because it's default value. If I will say 1.5, as you can see in x-axis, the cube was changed, it became bigger. So I can set 2, and now we have double size from initial default size. Same I can do with y-axis too, and with z-axis. So if I will remove, or let's put 111, and if we will put 111, we still have only dark theme, because actually right now we inside cube. That's, for example, let's imagine you are inside dark room without light, you will see nothing. Here actually happens the same, we inside cube. That's like we inside room. Let's change that position, 3, or oops, let's say -3. Now we see the cube. We just changed that position. Now we behind the cube. We're not inside. We just made like, let's say, 3 steps back. Now we're behind the cube. That's why we can see how it works. If I will set, for example, y -2, we will be able also to look above the cube. Let's change our color, because the white one is not the most suitable, since our window is white as well. Once we're referring to position or to scale, we actually refer to vector-free object inside Three.js. We can check in documentation what is vector-free, how it works. So constructor defines x vector, y vector, and z value of this vector, while position of any of vector, that's actually vector-free. The same regarding the scale. That's also vector-free. That means that we can apply any of these methods. We can use all these properties. For example, let's check, do we have DistanceTo? I click dot DistanceTo. So here it is. We can call this method. I'll explain a little bit later how it works. But anyway, actually that's very important to understand how these things works in Three.js. So instead of repeating cube scale 3 times in a row, we can say cube.scale, and there's such method as set. So we can set x2, y2, z the same. I've said it, and as you can see, we get the same result. I can say 2, 2, and 3. That vector we set 3, and now cube is a bit bigger. If I set 5, for example 10, it's becoming bigger in that vector. Completely the same we can do with position. So I can say cube position. Again, that's vector free. That's why there's set method is present. I can say set and say example same values, -3, 1, and -. So I had -3 in z, 1x, and -2 in y. 1. So now we're getting the same result, but our code is cleaner, it's much shorter, and it's more faster to write in this way. Next is rotation. Well, we can rotate our cube using rotation method. Let's remove scale and let's put this cube like this, not exactly in the center, to let you see the depth of cube. And let's check how rotation works. Rotation, that's not actually vector free, that's Euler. So it also has such values like x, y, z, but don't forget that's not exactly vector free, because you can get confused in order that it has also set method, it also has x, y, z, as I said before, but that's not the same. So we can say cube.rotation, for example, in x axis we will try to rotate, and let's say math.pi. So probably you already know that math.pi is 180. That's like a basic of math. And if you know to rotate a bit, for example, we need to multiply by, let's say, 0.4, 0.3, 1, and so on. So math.pi, that's a half of whole rotation. The whole rotation, that's 360 degrees, right? So to get the whole rotation, we need to multiply our math.pi 180 by 2. We will get the whole rotation. If I will multiply, it looks like nothing changed because we rotated completely the cube, and visually it looks the same. So if I will multiply by, let's say, 1.3, you see the changes. So we rotate our cube on x axis. I think to better understand what is going on, I will add here access helper. I wanted to add it later, but I guess that's the most, let's say, suitable time to do it. Const access helper. So we don't see our access helper now because its coordinates differs from what we have in cube. Let's change access helper position set. We put the same as we did for cube. And for now, let's remove the cube from scene. So that's access helper. We have Y axis, X axis, and this one is Z. Let's change the position of scene to let you understand better what is going on. So that's the Y axis, that's X axis, the red one, and blue, that's Z axis. Which means when we rotate our cube in X axis, this one, it will rotate like this. We can rotate on this axis. If we will rotate on Y axis, it will rotate in this way. So actually Y and X, that's fair enough. I'm not sure that we need to use that, but we can also actually rotate in Z axis as well. In most cases, you need only these two ones. Let's get our cube back. So we rotate in X axis. So that looks like cube rotates, let's say, ahead. And if we will set the rotation Y, so it rotated cube in Y. Sometimes we will get a lot of bugs when we change the order of rotation. So in this case, you will get completely different result if you compare in this one, right? Yeah, now in this example with cube, we have completely same result when we change the rotation order. We rotate first in Y axis and then in X. If we change that, we get the same result. But remember, sometimes we will get a lot of bugs, a lot of unexpected results just because you changed the rotation order. And to fix it, we can say cube rotation order is XYZ or YXZ. If I will save in this way, we will get same result. So let's comment. You can see nothing changes. But once I will put XYZ, you will get different result. And actually, this one is the most common use case in most cases when you will work with rotation. So now, once I changed our result differs, I guess that's because by default they're set like XYZ. Honestly, I thought that we will change this one or not change the result, but probably they're set order by default like XYZ. But usually I put YXZ. Will help you to prevent a lot of bugs. Well, method position length. It shows you the distance from default 000 position. So we change the position for our cube to 1, 0, -3. It will show you the distance from this default position 000 to our changed position. So let's check how it works. Cube position, again, that's the vector free, and vector free has such method like length. We can check length, and let's remove this console log. So we have 3.1 length from origin default position. If I will put, for example, -4 here, now we get 4.1. If I will put here -6, as you can see, the distance from cube to our camera also increases, and logically it also increases from the origin default place. If we will remove this position set, the cube will be set to this 000. We don't see it because we are like, let's say, in head of cube or inside the cube. So let's say scene position that is -3. So now we see the cube, but the cube position wasn't changed. It's still the distance to the origin is 0 because its position is 000 right now. But instead of changing the position of cube, we changed the position of scene. So we moved back, made 3 steps back, and now we see the cube and our axis helper. The DistanceTo method, while it calculates the distance between two 3D points, we can, this example, let's calculate the distance between mesh and new vector 3. And vector 3, when you create in this way, it sets 0, 0, 0 by default. So you will check position. So we will get the distance between mesh and this vector 3. In our case, if we will say cube position distance to new vector 3 and save, we will get the same result because vector 3 by default is created in the center of scene 0, 0, 0, right? If we'll put 1, 1, 1, we will get another result, 1.7. Also, we can provide here another vector 3. We have, let's say, axis helper dot position, and if you remember position, that's vector 3. So if we will save, we will get the distance between our cube and our axis helper. Distance is 3.1. If I will change the axis helper, that vector, we will get another result, 2.2. Let's say 1, 1.4. So that's the way how we can calculate the distance between two different objects. The next method is normalize. You may ask me, why do I need all these methods? First of all, and primarily, they will be used to debug, to measure maybe some differences, and they are very useful when you create and develop using Three.js. Normalize will put vector 3 to origin position. So we can say cube, let's normalize. And once I will call it, nothing happens since we commented the cube position changing. So if I will uncomment this one and comment normalize, as you can see, the position of cube was changed. Now it's 1 in x, y 0, and -6 z. So if I will say let's normalize the position of cube, it will set back to 0, 0, 0. So I save it, you can see it was normalized. That's how this method works. Okay, axis helper we used before, that's object. LookAt. This method calls from camera, and let's imagine we put a cube somewhere. Camera lookAt allows to move camera to exact position where this cube is located. So I will provide the mesh free cube position, and camera will be moved to the cube. So now we're still again inside the cube. So we can provide another vector 3, for example, new vector 3, 1, 1, 1, or here let's say -1. So now camera looking at this vector 3 and these coordinates, from these coordinates, that's why we see the cube. If I will comment this line of code, we will get back to previous results. Great, let's save our progress. So I'm gonna create a new branch, and let's call rotation and distance methods. You can get link for this repository in my Telegram channel, or you can simply switch between branches if you need something to copy, to check, to play around. If something doesn't work on your side, I guess that sometimes it's very helpful.